we are coming up with these equations for these systems, and then determining what my unknowns are, and then finding their answers. So we had color-coded this nicely, and we're determining how much, in terms of ounces of milk and ounces of orange juice, do we need to meet our daily required calcium and vitamin A, whatever we call it. What would we call it? Daily required, what do they call it? Huh? Intake? Oh, intake's a good word. Daily required intake. All right, so we had all of the milk and OJ and total calciums in green, and that was where our 38 and 5 for OJ and 550 for total came in. And we said that all of those, because they're dealing with calcium, are going to create one of our equations. And then we did the same thing for vitamin A. Again, milk has vitamin A, 56. And then we have 60 for OJ. And then 1200. Okay, so the recommendation, right? Put a table together. Put the table together, because the table can help you figure out how to use these numbers here to create my equations. And you want to, just like we were doing with our rate problems, when we had rate equaling a rate, I want the same thing happening with this. I want all the calcium numbers to become one equation, and I want the vitamin A numbers to become one equation. So here's what we end up with. Oh, wait. We must first define our variables. So we're going to let M equal the number of ounces for milk. And then we said J, the number of ounces for orange juice. Remember, define the variables. Definitely need that when we're writing these equations. Okay. Here we go. So we'll call it equation number 1. And our milk equation, or our calcium equation. So I have 38, and then 5, and this is supposed to equal 550. And then we just stick the appropriate variables in there. So 38 is for the milk. And we're going to add that to 5 for the orange juice. And that became our first equation, number 1. Then we did the same thing for vitamin A. We had 56 times M. 60 J 1200. Now we're going to solve it. But before we solve it, questions on where these numbers were coming from. I ran through it real quick yesterday. Do we understand why we're setting it up? Why aren't we going 38, 56? Why are we going across? They're different things. They're different. You're talking about different units. If I went across, I'd have 38M and 56M. And that doesn't have my other variable. I need all my variables in there. So we got to go all calciums, all vitamin A. All right, then how do we set this one up? What would be the suggestion here? Would we want to substitute? Do we want to do elimination? What might be the easiest? So, yeah, you want to substitute? Okay, you want to? Okay, make up your mind. You want to eliminate? Okay, so what do we want to eliminate? Okay, when we eliminate, we're choosing to get rid of the variable M or the variable J. Great idea. So what do I need to multiply this equation by so that I eliminate variable J? Negative 12. Good job. All right, so someone's going to have to help here with the numbers. Let me see. In my head, 38 times 10, 380. 2 times 38 is 76. 380 plus 76 is 456. Is that right? Oh, yeah. So 456M. Well, thank you. And then minus minus 60j. Wouldn't it be negative 456? Of course it would. All right, and then negative, okay, we got 550 times 50. Oh, where did I get the negative 12? Great question. Who asked that? Shy. All right, where did we get the negative 12? I am trying to, or Simon suggested that we eliminate, see the j's? I've got 5j's and 60j's, and we're trying to make one of them opposite, so we multiply the 5 by negative 12. All right, so 550 times 12, 550 times 10 is 5,500, plus another 1,100, is that 6,600? Oh, man! Minus 6,600. All right, now that's new equation number 1. Equation number 2 stays as it is. 56 m's. Get my shadow out of the way. 60 j's and 1,200. Now we're going to go ahead and solve. My j's are going to cancel, and I get negative 400 is equal to, remember those guys go bye-bye. What do we have? Negative 54. Then I'm going to divide by negative 400. Somebody, so we can do this quickly. What are we going to get here? 13.5. Thank you very much. Now, it's nice that our units are positive because we're talking about ounces of something. So I can't have negative ounces. So if you get a negative answer, you made an oops somewhere in setting up your problem. So there it is. M is 13.5 ounces of milk. And then to find J, what do I do? Plug it in where? M? Into M. And I can plug it into any of the equations, correct? Correct. So we can plug M. Let's say we want to go into equation 1. Then I'd have 38 times 13.5 plus 5j would equal 5. All right, then we're going to get 5j equals, somebody's going to knock out 38 times 13 and a half, and then subtract that from 550 for me.
37.
Thank you, what?
37.
You mean that's what j is, or that's what?
No, that's like
So 550.
that equals 550. It's 513, and then 550 minus 513 is 37.
Okay, so 550 minus 5.
13.
Okay, so I get, what did you say again? 37, thank you very much. And then divided by j, let's give me a decimal, since we have this one in decimal. What are we going to get there? 7.4. 7.4 ounces of orange juice. And there we go. Bless you. So that's how many ounces of orange juice, how many ounces of milk that we're going to need in order to provide the daily 550 milligrams of calcium and 1,200 milligrams of vitamin A. 7.5 ounces. Anyone have an idea how big that is? See that water bottle sitting on Evan's desk there? How big is that water bottle, Evan? 16.9 ounces. So about half of that is what you would need to get your calcium from OJ, and you need just a little less than that if you're going to get your calcium from milk. Now, these are just made-up numbers. Probably in reality, I'm thinking milk probably has a better calcium production than the OJ does. Any questions on those? Okay, let's move on. You guys get to try it on your turn. Where is it? There we go. Here we go. So these distance problems, remember we had work is equal to rate times time? Well, now you can have distance equal to rate times time. Rate is the same thing as your speed or your velocity. So we're going on a little plane trade winds, which means your plane is getting affected by the wind pushing against it. It's got a headwind, so it takes longer. And then when you go from San Francisco back to DC, you're flying with the trade winds, or the jet stream. And then that means your plane is being aided by the jet stream. It's pushing it. So it takes a shorter amount of time. Do you guys know that stuff? Oh, yeah. Good. Good right there. It's always nice when the wind is helping you. So once again, we set up our table here. We've got with and against. What do you think that means? Yeah, with the wind and against the wind, right. So when I'm flying with the wind, we say it's helping me. So I'm going to be aided. And if I'm flying against the wind, it's going to be pushing against me. So now we got to come up with the equations for this thing. And once we have determined how I use this D equal RT, then we're good. So let's see what we've been given. We've been given 2,400 miles, that's a distance. And then we've been given time. The question is, assuming that the plane travels at a constant airspeed, and the wind is also blowing at a constant airspeed. Finding the plane's airspeed and the wind rate. So there are unknowns. So we can say let P equal the plane speed. And W can equal the wind speed. There we are defining our variables. So what are we looking for? Are we looking for a D, an R, or a T? Is it a distance we're looking for, a rate we're looking for, or a time? We're looking for a rate. We're looking for a speed, so we're looking for R's right here. These are rates. All right, so again, it's helpful to do the table. You don't have to do the tables, but it's I think it's probably helpful for us. Okay, let's think about our distance. If I'm going from San Francisco to DC, it's how long? 2,400. And if I fly the other way, is it still 2,400? Yeah, that doesn't change. So going with the wind or against the wind, I'm still flying the same distance, 2,400. Okay, now here comes the other known thing, our time. We're going to take care of the rates in just a second. Our time flying with the wind is shorter, and so that takes us 6 hours. And flying against the wind, we fly a little longer, which for people like me who love to fly, that's always good. 7.5 hours. Okay, now here comes the tricky part. This rate thing. What is our rate going to be comprised of? It's going to be made up of two things. Well, we already have the time. So here I am, ready on the plane, and I'm flying at my velocity, either with or against the wind, right? Here's my speed. Okay? Say I'm flying with the wind. What's the wind doing to me? So I'm going to go faster or slower? I'm going to go faster. So is my rate going to be bigger or smaller if I'm flying with the wind? Okay, and then what are the two things that make up that rate? No. Speed of the plane and the speed of the wind. Beautiful. I've got two things making this rate happen. My speed is an airplane. And then the wind either pushing again. What are you doing with that?
I just accidentally touched something.
My speed is an airplane, and then the wind either pushing against me or with me. So, here we go. Ready? Plane and wind. Plane and wind. What do I stick in between them? Do I stick plus signs for both of them? Which one gets the plus sign? Which one's going to make the bigger rate? With the wind. So when I'm flying with the wind, my speed will be faster because I'm combining both the plane and the wind together. And then what do I do when I'm against it? I'm subtracting because I'm flying into the wind, and the wind is going to go on 100 miles an hour. The wind is pushing at 20. That means I'm not going 100 anymore. I'm flying less than 100 miles an hour. So I'm going to have this. So there's my rate. My rate is made up actually of my two unknown things. So in this setup, you guys paid attention to this, I have distance equals rate times time. I'm just using d equal rt to write my equations. I will have two of them. One as a with the wind equation and the other as an against the wind. So we can call equation number 1, 2400 is equal to P plus W. There's my R times 6. Equation 2, same distance. And now the wind is pushing against the airplane, headwind, and it takes 7.5 hours. Now, before we even wrote those down, did anyone think they actually had that? No? Ideas? No? Can you see that there, Brooke? Sorry. Okay, do you think it's a good idea to leave those two equations looking like that? Why not? Why isn't it a good idea? We want to set up a system, right? And I'd like to probably keep R or P's and W's with their coefficients in front of them, so I'm in standard form. It's not that you can't solve it this way, but it's probably better for us to do this. 6P, distribute the 6, and 6W. Do the same thing here. Whoa, not 24,000 miles. That would be a long plane ride. 7.5P minus 7.5W. Now you have standard form, and then you can set up your substitution or your elimination. Yes, sir.
You just divide like the first one by 6, the second by
Great idea. There's always a fork in the road when it comes to these problems. So Jordan's question, can I take problem number 1 and divide 2400 by 6 and just get P plus W? What do you guys think? Can I do that? Has he violated any universal laws of mathematics by doing that? Yes or no? No. No. He didn't violate anything. And equation 2 would then simply become 2400 divided by 7.5, so you got to give me the decimal of that, would equal P minus W. And then I can go work out the problems from that. Who's got that? 2400 divided by 7.5? What is it? 3. Is it exactly 320? So yeah, you have some choices. You could get rid of that constant time value, divide out the time so you just get rate. Or you could distribute the time through and then go after your elimination method. Now, by dividing by the t and getting 400 equal P plus and 320 equal P minus, it's very easy to see elimination-wise what happens to W. So I can have 720 is equal to 2P. That means P is equal to 360 miles per hour. There's the plane speed. And then if I wanted to find W, I'm just going to use equation number 1 again. 400 would equal P plus W, or the wind speed is 40 miles per hour. Way to go, Jordan. You get the same answer if you had worked with the 2400 equals 6P plus 6W, if 24 equals 7.5 plus or minus. Same thing. the business world here. I produce something. I will produce more or less of those items depending on the demand for that item. So if you guys are in your economics class, you're probably learning something about this supply and demand. As the demand goes up, supply should also go up, and vice versa. Supply goes down, the demand doesn't necessarily have to follow the supply. Right? So if I stop producing iPads, that doesn't mean the demand is going down. The demand can still be up, and my supply is just not necessarily a converse relationship. All right, but cherries. I have a cherry tree in my back. I have 2 cherry trees. And what? Of course. They're Mount Rainiers and beans. They're delicious. Well, I would bring them in, but sometimes when my kids pick them, they eat them in the process. So, but I put the hammer down. No more cherries. Okay. So we're selling these cherries, and P is going to represent, here we are defining our variables already. I think. Q, a quantity in thousands of pounds. P, the price in dollars. All right, so this problem, we've already defined our variables. I wouldn't need to state that again. It's already defined in the problem. The equation has already been given to you. Again, I could take some information and allow you to create this equation. But in this case, we've already been given the equation. And probably what's happened is, after a period of years, maybe this farmer, if this is a farmer that's doing this, coming up with the supply and demand, they've gone and they've kind of kept track of the data of their crop, the production of their crop, and then over the course of the summer when you're selling your cherries, what was the demand? And they've kept this data over 10s years, 20s of years, whatever, and then they formulated these equations here. That's what farmers do. They don't want to just guess. They're not going to speculate. They're going to do some statistics and mathematics to come up with something that would be helpful for them. Yes, sir. Are you raising your hand, or are you just okay? You're just stretching. All right. All right. So we got these P's and Q's. Does this look difficult? Because look, where is my question? My question is, at what price? So here's the only thing you got to be careful with these problems. Sometimes you get in the mode of a system, you start going to find P's and Q's, and you don't even look at what the question is asking you. So this is saying, at what price will the cherries stabilize for the day, or at what price will the supply equal the demand? Now we're getting ourselves into something called a break-even analysis when we do this. When our supply equals our demand, this can be used to show a break-even point. We're going to get to those a little bit later. But the concept of breaking even is those two have to be the same. The supply and demand have to be equal at that point. And when that's going on, that's good. That's harmony within the farming business, right? When your supply and your demand are the same. Right? So it works not just for farms, right? It works for anything, whether you're selling electronic devices, whatever it is. You have, hopefully, a point where I've got supplies and demands being equal. If you're starting up a new company or a business, you go and you rent a building, that's a cost to you. And then you have to buy office furniture and equipment to fill up that building, and now that's more of a cost to you. And then finally, you hire employees, and there's an additional cost to you. So you have all these costs happening, and then you start to sell your product. And what you hopefully are going to do as that company matures is there's going to be a time when the money you're spending, which is called your expenses, and the money that you're bringing in is called your income. There's a time when those are going to cross each other. And you want that income to obviously exceed your expenses. And at that point, you have been profitable. So that's what this does. All right, so how would we set it up? What would we do here? If we're looking for the time when supply and demand is the same. Yeah.
Could you use substitution?
And substitute them how?
Like, so since they're both equal to P,
They're both equal to P,
So-
which is the price.
so put them on opposite sides of the.
Yeah. So if I'm supposed to be its place, now it's a giveaway, right? It even told us supply is equal to the demand. Both of these are price values. One of them is a demand price, one of them is a supply price. So yeah, I'm just going to set one P equal to the other. So again, if we just want to call one of these equation 1 and one of them equation 2, we're going to set 1 equal to 2. They're both P. So we have negative 0.3 Q plus 5. There's my demand equation. And that's going to equal my supply equation, which is 0.06 Q plus 0.68. There we go. This is your break-even point. Move all my Q's around. I like to make my variable terms become positive. So I'd add 0.3Q to the right and make that one go this way, and bring the 0.68 to the other side. And I would create a situation where I have 4.32 is equal to 0.36 Q's. All right, calculator people. Give me an answer here. 12. All right, now we have to look at, here's the other thing with application problems. I don't want to just give numbers. I need to define what they are. We've already defined Q as a quantity in thousands of pounds. So I'm not going to trade 12. I can do one of two things. I can do this. I can write it like this. It's 12 in thousands of pounds. Or I can just write it as 12. But I gotta have the units in there, so either make the number 12,000 or just say 12,000 pounds. Okay, now let's make sure that we've answered the question. At what price will the cherries stabilize for the day, or at what price will the supply equal the demand? Have we answered the question? Yes or no? No. We haven't found the price. All we did was find out how many thousands of pounds you need to have in order to make the prices the same. So we're not done here. This is just the amount. We need to go find the price that happens to create this situation. So we got to go find P for this. So using equation 1, for example, we got negative 0.3 times 12,000. So here's where you got to be careful. If I did that, I'm going to have a little different problem. We actually want to just use 12 because we're talking about in thousands of pounds. Plus 5 here. So I get a third of 12 is 4. So negative 4. Oh, wait. That's 30%, not 33%. So 30% of 12 is 3.6. So P is equal to 1.4. Now let's go look at what P is. P is our price dollars. Okay, but here's the question. Is that dollar per what? I think that is dollars per created that 12 with 12,000, then I'd have 1,400, and that would be per 1,000 sometimes. So this is per 10. There's what we wanted to find. We didn't need. We needed the Q, but we had to find actually the price. Don't just sit there. Thinking is one thing, but just sitting there, waiting for me to do it. All right, here we are. Okay, we've talked about what all these terms mean. A fixed cost is a one-time expense, and it is coming out of my pocket. So it is going to be an expense, and there it is, $320,000 as an expense fixed cost. Then we have a variable cost, and these are the guys that change per something. In this case, I have a per book. And what that means is that's how much it costs me to make the book. That's how much. I have $320,000 for all the equipment, the building, whatever that is, and then I have $31.25 to make every single book. That's the labor that goes into it and the material that goes into it. And every time I have the word per, the word per means you're going to multiply with the variable. That's why they're called variable costs. Brilliant. All right, so we're going to define our variables here before we get going any further. So we know that 3125 is going to be a part of my equation. What are we looking for? We are looking for how many books must the publisher sell. So we have, let's say, B equals the number of books. So if I have $31 per book, that means in my expense category, underneath cost per items, I'm going to have $31.25 times B. If I make 2 books, it's going to cost me $62.50. So on and so on and so on. All right. Wholesale. That's what you're going to sell it to the public for. That means that's money coming into your pocket. Notice that the wholesale price is larger than the cost price, and that's good. If you don't have that, you're never making money. So your wholesale price needs to be bigger than your cost price. You're making a profit per book of how much? What's your profit per book? $12.50. Add $12.50 to $31.25, you get $43.75. So every book you sell, that's $12.50 in my pocket that I don't have to send out anywhere else. So this is an income then. That's an income because it's a wholesale price. So that is a per thing. So that's this number right here. Now, in terms of a fixed cost for income, I don't have that in this scenario. Give me, though, maybe something, let's create a scenario for this situation where there might be a fixed cost. Say you're selling the book at your bookstore. You're going to sell it $43.75. But then what might you do to add a fixed cost? Yeah.
Tax.
No, that's actually a variable cost because that depends on the price of your book. But that's a good guess. Maybe not so this example might not be the best one to talk about fixed costs. Let's talk about gym memberships. When you join a gym, tell me what you usually, does anyone here join a gym? You guys walk out or anything like that, huh? So do you have a gym membership? Yes, okay, so where's your gym membership? Yeah. Okay, and when you joined 24-hour, tell me something, what did you pay?
I don't know, but it was cheaper than it is now.
Okay, but do you remember it all having to do with like initiation fee?
Yes.
Okay, now is that initiation fee something you pay every month? It is a one-time cost. So that would be a situation where I'd have, in addition to my per item, like for the gym membership, you're paying per month. But you would also have initiation costs, right? So I could have these these fixed costs under income. But in this example, we don't have. All right, so then I have all my equations. I'm ready to set this thing up. I've got my income equation and my expense equation. So I equals income is equal to $43.75 per book that I sell. My E being my expense is equal to my fixed cost, 3125 B's. All right, there are my two equations. And some of you guys have that. That's good. Okay, what form are both of these equations in? What form is this one in? I. Wait, let's back up. Let's back up. What kind of equation is that? Come on, people. What's that going to graph? If I were to graph a line. So it is a what kind of equation? Linear. And it is a linear equation in which form? You got standard form, slope-intercept form, or point-slope? Which one? I got slope-intercept. I got standard. Do I have a C value? No. I have a y equal mx value, what I've got right now. So this is a slope-intercept form, where my C value is equal to 0, or my v value, my y-intercept. So these are both the slope-intercept form. So it has slopes. Slopes, by the way, if you haven't already made this connection, are always going to be these cost per things. Those are going to be my slopes if we're talking about a linear situation. And so once I have that, what am I going to do to answer the question? So I have my two equations. What are we going to do? How many books must the publisher sell to break even? Make them equal to each other. Why? Why? They're break even. Break even is where my expenses and my incomes must be the same thing. And so if they must be the same thing, I set the I equal to my E. And I get that 43.75 B's would equal 320,000 plus 3125 B's. And then I'm going to go find my answer. Now, when I find B, look at the question. The question is how many books, not the cost. This question is just how many books. So when I set this over here and I get my 1250B equal to 320, somebody calculator, get me ready. How many books am I going to have to sell before I break even? Whoa, what is it? What number? 25,600? Look at that. So before I even start to realize a profit, I have to sell that many books. That's a lot of books. But think about if you're a publisher for like a textbook for schools, they do that easily. Right? Although maybe not so much anymore because now things are going digital, but that's how many books I'm going to have to sell before I would break even. Now, can I find the cost? Can I find out how much money that's going to make me? Brian's shaking his head. Are you shaking your head for a reason? Because you know what the answer is? You're just shaking your head. Okay. We know the cost. Or the profit. I should say not profit. The income that I can have if I have 25,600 books. Can I answer that question? How? Plug it in. Plug 25,600 into either I equals 4375B or into E equals 3. Now, it doesn't matter. Those are going to be the same numbers. E and I are going to be the same right there because it's a break-even point. It's going to have the same dollar amount associated.